So I'm going to go through this. I don't have a script. I'll have the code available. Probably the GitHub link will be in the description. But here's what I did. I took the traveling salesman problem, which is simply like how do you go from one place to another place visiting all the cities in the lowest cost. And it's known to be an exhaustive search sort of problem that you have to do. And it's often used in coding interviews or just, what do they call them? The exercises that you're going to do just to get ready for something like a coding interview. So what I did is I implemented it two different ways in Rust, Python, and TypeScript. And doing so in order to sort of take a relatively simple but yet complex in how you can implement that, and doing it in both generics and very straightforward ways, and then different languages, and looking at the results. So let me look at the results first. So the README file has a summary of the results, and here it is. And really, if we look at this, the benchmark is doing a small sequence and calculating how long it takes to run that. And I'm using the standard benchmarks criterion for Rust. Python's using PyTest is no, what is it? Whatever the benchmarking, I'm using just kind of commercial benchmarking systems. So it's doing all of the work to kind of preload it and warm everything up to make sure it's not sort of hitting the cache for the first time. So here are the results. The Rust version, I have really two, but kind of three that's shown here. There's a hand rolled one, which does it in 1.3 milliseconds. The Rust generic version does it in like 1.6 seconds, and the other kind of version of this does it as well. So, the once you start ramping this up, like the differences between this hand rolled one and the generic one is almost negligible. So, we're talking about, very fast here. Now, the next best is the hand rolled Python, which is 40 times slower than Rust, which, is probably to be expected. This one that says referenced is 100 times slower, like almost twice as slow as the hand rolled version. And unfortunately, this is the version that is using some great features like generators in Python, and it is considerably slower. TypeScript, a little bit better compared to the hand-rolled one versus using what amounts to generators or iterators in TypeScript. But we're still talking like 100 times or more slower than the compiled version. So takeaways with this, and then we'll go look at the code. For one, hand rolled versus generic, really no difference. That's kind of what Rust is known for having abstractions that don't cost anything. In Python, very disappointed here that the generic version that's using, well, it's not exactly generic, but it's the version that's using generators is notably slower. This one in TypeScript, the differences between the hand-rolled and the generator version, it's not as much. I'm not as concerned about it, but it's still so slow compared to a compiled version. Let's look at the code. So Rust is doing everything with generics. So we have this destinations. We have a destination, basically a destination and a distance. So we're given the set of inner destinations. These are the cities that we need to visit, and we have a start location and an end location. And those start and end locations are not in the destination list. They could be, but ideally they're not. Here's where I want to start. Here's where I want to end. How do I travel through that? So, and then we give it a distance function. How long does it take to get between two different points? And the destinations is an iterator. Destination itself needs to be cloned, and that's done because of the permutation function. And then distance is just something that can add things together and be able to be compared against each other. Typically, this is just going to be a number, an I32, U32, F64, something like that. The algorithm here is getting all the permutations, and this is an iterator. So permutations here, let me use the hints. It is returning an iterator of a vector of destination. So the permutations method through itertools is going to give me all the permutations, all the combinations that you could have for this. And we're just filtering ones that are empty, because if you pass it an empty list, it's going to give you one empty thing. All the distances, we're mapping over that, and we're getting the distance of the inner loop here. And then we add how long does it take to get from the first one, or from the start to the first one, and then from the last one to the end. So this is getting the total distance. We're storing that as a tuple, or returning that as a tuple. Distances here, this is when the code actually does execute. So all of these are lazy executors. Really important when you have just a ton of these. You don't want to create a vector of stuff. And in all of these, that's what I'm doing. I'm using lazy evaluations so that we're not pre-generating arrays and walking through these arrays multiple times. So this is the generic version. The non-generic version, the hand-rolled one, might look similar and also maybe more familiar. So we go through all the permutations, and then we hand calculate how long does it take to get between two different pairs. So in this case, I'm using indexed pairing to be able to access an array or a slice of values and getting the absolute difference between those two. And then we are computing the distance from the start and the end, similar to what we did up above. And then here's where we do the comparison. Is this the minimum distance? And if it is, we're going to keep it around, and then we return it. Nice and simple, works great, and is obviously very fast. Python. So the Python version is here. And I'm trying to be as close to I can as sort of the Rust version, where I'm using iterables and generics in order to create and walk through things. So like this start list end is going to yield the start value, all of the items in between, and then the last value. So this is just how do I compute what this list is. These are all the routes. So given all of the inner destinations in between, we're creating a sort of a generator of generators. And it's just a way to have sort of that inner loop in there. The total distance, we just do this pairwise, which is part of itertools, I think. And it's just getting the two pairs next to each other, and we sum them all up. So this is all, again, lazy evaluations. Really nice. This is what the pairwise is doing. So the Traveling Salesman version's almost the same. We get all the permutations, we get all the routes, and then we go through all the routes and we compute the distances. This is not supposed to look like this. This is supposed to do this lazily. I'm going to fix that. We shouldn't be accumulating this. You know what? Let's see if we can have do this with lazy evaluation and generator We'll see if this will fix it. Not going to change the cost that it takes to do this. We shouldn't be accumulating this all. We can do this all by hand. Okay, the hand rolled is sort of similar. We're just doing, we're going through all the permutations and kind of inline. We're computing and accumulating the max distances. It's very straightforward. Okay. You know what? That's fine. I'm okay with that. While that's cooking, let's go to the TypeScript version. Here it is. And similar sort of thing. I'm trying to use iterables and generators to compute everything. So calculate distances is a generator. It's going to yield values, start and end, similar sort of thing. It looks very much like the Python version. Looks very much like the Rust version. All of this is doing lazy evaluations. Works really well. Okay, so I'm just going to leave this here. You can sort of draw your own conclusions with this, but this is sort of the basis for looking at, where do we get the value out of this? This actually is important here, I would say, is that these the code complexity, the Rust version is the most sort of compact. It thinks that it's the cleanest version of them all, and was honestly probably the easier one to write. It's compiled. It's checked at compile time. Everything is managed with it. You know that it's going to work. Python is doing some type checking. TypeScript is doing some type checking. There are certainly gotchas in there. Again, just letting this sit. This is more sort of food for thought. What does this mean? What does this mean when we blow this application up to have more feature-rich systems? When we need to rely on the compiler and type checking more, are we getting the best bang for our buck out of whatever language you're using? I have my opinions. If you've been watching this channel long enough, you know what my opinions are. I think those conclusions are pretty obvious, but, use your own head, come up with your own thoughts, leave them in the comments, do whatever you want. Cool.